Uh, Good day, everyone. My name is Martin Narayan. I'm studying IB1, and today I'm going to be talking about mass spectrometers in this video. I'm going to talk about what mass spectrometers do, how they function, and I will be also showing you a model that I created using basic household items. So, first things first, what are mass spectrometers? Well, mass spectrometers are scientific devices or pieces of equipment that accomplish two things. Number one, they help to detect or calculate the relative atomic mass of a particular element. Let's take chlorine as an example. Chlorine's AR, or relative atomic mass, is 35.5. A mass spectrometer would be able to detect that using its process that we will talk about in a bit. And the second thing it does is kind of related to relative atomic mass, is the detection of the isotopic compositions. So let's talk about chlorine again. Chlorine has two main isotopes, chlorine 35 and chlorine 37, and the calculations give you 35.5 for the relative atomic mass. A mass spectrometer can do that for you. And there's a kind of a long process as to how it does it, which we will talk about in the next segment. Okay, now we can start talking about the process now that we can see the model in front of us. There are 5 different stages in a mass spectrometer device. Some can say 4, but it's usually considered as 5. So I will take you through all of them and explain to you how the device works. So before any of the processes start, the sample element needs to be inserted into the mass spectrometer. This can be represented by these studs here. They're inserted into the device with this contraption, which represents an inlet, basically an entrance into the mass spectrometer that allows the gas, or not the gas, but the element to enter the contraption. The first stage is a pretty simple one. It's just vaporization. This is where the heating filament, represented in orange, heats up and vaporizes the sample element into the gaseous state. Therefore, it has the highest kinetic energy, and yeah, that's basically it. The second stage is ionization. This is where an electron beam source bombards the gaseous state sample element and creates positive ions in the process. And segueing into the third step, which is acceleration. These two plates here, represented by Play-Doh, are negatively charged, and the laws of attraction tell us that opposites attract, right? So the positive ions and negatively charged plates are attracted to each other. So these positive ions will want to move towards them, and they will increase or accelerate and go through them into the second part of the mass spectrometer. In the second part, we reach the last two stages of the mass spectrometer process. The fourth stage is deflection. Basically, this is where a magnet, represented by the positive and negative, or clay balls, deflect or change the trajectory of the different weighted positive ions. So the less mass an ion has, the more it will deflect, as we can see by these two lines here. These definitely have a different trajectory as compared to this one. This and this one, the one that is going completely straight in a regular trajectory, is an ion that has a higher mass, a higher weight. And in the situation where there's a higher weight or higher mass, it can either deflect very little, or it could not deflect at all and just go on with its current trajectory. And they travel until they hit this thing, which is a detector. And that brings us to the last step of the mass spectrometer process. This plate, is a detector. It, as in the name, it says that it detects when the positive ions reach and hit this detector. This detector, when the positive ions touch this or come in contact to this detector plate sends out an electrical signal, electrical charge, to the computer that is connected to the device, to the mass spectrometer in itself. And that computer will process the data and give us the desired outcome, depending on what it might be. And that's essentially it. That's the last part of the mass spectrometer contraption. So, to summarize, it starts with vaporization, and then goes on to ionization, then to acceleration because of opposites attract, then deflection because of with the magnets, and then lastly to the detection, which is the last phase. Detection then goes to the computer, which processes the data and gives us the desired outcome. And I will show you what a sample outcome might be in the next section. Okay, this is the last part of the mass spectrometer video. This is essentially what is going to show up on the computer after the data has been processed. It talks about the relative abundance of the different isotopes that a sample element might have. In this case, it's boron.